Spherical mirrors. To develop an understanding of how images are formed by any mirror or lens, it is useful to understand that light rays coming in from a distant object are effectively parallel. Spherical mirrors are shaped like sections of a sphere and may be reflective on either side. If the reflective surface is inside, the mirror is called concave. Parallel incident rays reflect and converge to a focal point. If the reflective surface is outside, the mirror is called convex. Parallel incident rays reflect and diverge away from a focal point. When describing and working with spherical mirrors, there are two important points and their corresponding distances from the mirror. C is the center of curvature. It means the center of the completed sphere. R is the radius of curvature, the distance from C to the mirror. Capital F is the focal point, where the reflected rays converge, and lowercase f is the focal length, the distance from F to the mirror. Sometimes C is represented as 2F. The line that passes through C and F is called the axis of the mirror. The focal length of a spherical mirror is half the radius of curvature. That is why sometimes you might see 2F instead of C. For mirrors with large curvatures, parallel rays do not all converge at exactly the same point. This is called spherical aberration. But if the curvature is small, the focus is much more precise, and the spherical aberration can be neglected. For our purposes, most of our mirrors will have small curvatures. We can use ray diagrams to determine where the image will be when using a spherical mirror. We draw 3 principal rays, although 4 are listed here. 1. A ray that is first parallel to the axis and then after reflection passes through the focal point. 2. A ray that first passes through the focal point and then after reflection is parallel to the axis. 3. A ray perpendicular to the mirror and then reflects back on itself. And the last one, a ray that strikes the mirror at the principal axis at a certain angle and then reflects back at that same angle. Really, in order to draw a ray diagram and see where the image will be formed, we only need 2 of these, and usually we pick the first 2.